Hi, class. Okay, so welcome to the second day of lecture. I hope you're all getting settled into using Canvas, getting connected at Pearson on mastering, and everything is going well. I know I've been answering a few emails from most of you, so if you are still having trouble, please keep emailing us. We're working through most of those difficulties, and I think everyone is slowly making progress. So we're going to continue our discussion today about astrobiology. And in particular, we're right at the beginning of our study. And what we said last time was we just kind of talked about what astrobiology was. But what we want to do today is really talk about, okay, how are we going to approach this? How do we actually get started in this game? And so what we're really doing right now is laying the blueprint for the way we're going to approach this topic for the rest of the quarter. So let's take a look at this section of the lecture. I'm going to share my slides here. Keynote share. Okay, so how do we get started with this question of how do we search for life in the universe? So this is a very famous woodcut. Well, actually, we don't know if it's a woodcut. It's a very famous diagram from the 19th century. It's called the Flammarion diagram from the book that it originally appeared in. We have no idea who the original artist was, but it's a diagram you often see, and we use it quite often in astronomy. We use it quite often in philosophy and history because it inspirationally represents the journey towards wisdom on whatever version of that journey it may be. And in our case, we're looking out into the universe and trying to discover something of ourselves. So how do we start this search that we're engaged in? So the way we're going to frame this is there's basically two challenges to starting. And we're going to talk about both of these at great length throughout the rest of the quarter. The very first challenge is how do we define life? And then the second challenge right here at the beginning is how do we estimate our chances of finding life at all? Okay? So when we start talking about anything in science, really any problem that you're trying to solve, you really have to know what you're talking about. So we're already moving along. We've already had one full lecture of class, and here we are at the second one. Like, we know what we're asking. But fundamentally, we can't really even start talking about astrobiology unless we can answer one simple question. And that one simple question is, what is it we're looking for? Now, you may shrug your shoulders at that question and say, well, we're looking for life, duh. But the real question here is, what is life? If we say we're going to look for life, we have to know what life is actually all about. And that's what the question is, okay? Now, we're going to expend a great deal of thought trying to answer that question over this quarter, okay? And we're going to talk about it from many different viewpoints. We will probably alternate between despair and confidence in that we know what life is, okay? That's part of the game, that's okay. But today, just for the discussion today, I would like to propose the following maxim, the following idea that we're going to adopt, okay? Which is, we're going to know what life is when we see it, okay? And some of you may be like, okay, sure, that sounds great. But others of you may be thinking, well, that's kind of naive, right, Larson? And in a way, it really is. And we'll come back to that naivety eventually. But I want to argue today that this is a perfectly acceptable starting place. In the absence of having any long discussions about what life is, if I had just walked up to you on the street, or if you and I could both go out in the backyard together, in fact, I encourage you to go out into your backyard, this would be a perfectly acceptable starting place for this discussion. And the reason is because if you go out in your backyard, you can clearly recognize things that are alive and things that aren't alive. Okay, so, you know, if I step out in my yard, these are the sorts of things I see. I see all kinds of different things. And there's a whole group of those things that clearly are what we would call alive. There's a whole group of those other things which we would clearly say are not alive. Okay, and so this is what I mean when I say we want to adopt the idea that we will recognize life when we see it. Okay, now acknowledging the fact that that may be a little bit naive means that there are absolutely things here on Earth where it may be hard to categorize it into one of these categories or the other. okay? And we can make long lists and long examples of those things. Here are just a few things that I grabbed pictures of, and some of you, if you've been trained or if you've had experience or exposure to these things before, or you've read about them, you may know that they're alive. But if I just handed you a sponge, you may not know that it was a sponge, a living sea sponge, or a synthetic sponge. Maybe you didn't even know that sponges came from living sea sponges, okay? Platypuses, clearly alive, but they're a little weird looking, right? So how do we know? Yeah, okay. So this is the point, right? Even here on Earth, there's plenty of weird life. And there's plenty of weird life that we may or may not recognize when we see it. And that's part of this story that we're going to learn this quarter, is that even on Earth, we're still learning to recognize life, which is helping us understand what sorts of things we should be looking for in the astrobiology world. Okay, and we'll come back to that theme again. What we're going to find is that you and I, ultimately, we're going to try and establish a set of rules. This is what astrobiologists do all the time, a set of rules that we use to identify what life is. And what we're going to find is that, as with many of these things that I'm showing you on the screen right here, sometimes it's hard for the rules that we set out to define what life is to always work the way we intended them to. And that's a theme we'll come back to over and over again. Okay? But by and large, let's adopt the maxim that we'll know life when we see it, okay? So the next part of the question then is, how hard is this really going to be, okay? I think most of us have learned by now, before you pick up some big project, before you decide to take on a project at work, before you decide to register for a class in school, before you decide what a term paper topic is going to be, you ask yourself, how hard is this really going to be? And there's many reasons you ask that question, mostly because you're going to have to invest some work in it, okay? And you got to decide if you have time to work on it. But also you want to only attempt projects which challenge you, certainly, but for which you know there is some reasonable chance of success. In other instances, you may decide that the payoffs of doing the project are not worth the effort and the time and the challenge of it, and so on. And those are certainly things that we consider as professional scientists. But in astronomy, especially when we're asking questions about the nature of the universe, we almost never shy away from the fact that questions can be hard. We're perfectly fine with questions being really hard. We're perfectly fine with the idea that questions may be difficult to answer, okay? But the reason we still ask the question, how hard is this going to be, is because we still have to plan. We still have to know what's going to be involved in the attempt to answer the question that we're asking. We need to know how we have to train students. We need to know what kind of equipment we're going to need. We know we need to figure out how long the experiment's going to have to run, how to plan for it, what kind of facilities we'll need. We need to basically decide, what do we have to learn before we can answer the question we're going to answer. So scientists always ask this question no matter what, even though we may very happily pursue a question that may be impossible to answer. And answering the question of whether or not there is life elsewhere in the universe is one of those super hard questions that, as we discussed last time, we're not sure we'll be able to answer or not, okay? But it doesn't matter. We're still going to pursue the question. We just want to know how hard it's going to be so we know what to do to kind of keep the project moving along, okay? So how are we going to figure out how hard this is going to be? Okay, so I'm going to propose that this quarter we use a very famous equation in astrobiology always to guide us, okay? And those of you who have studied astrobiology before may have heard of this. This is called the Drake equation. And the reason I like the Drake equation is because it's much more powerful and flexible than you may have ever heard that it was. When the Drake equation is usually talked about, it's talked about very specifically in the context of searching for extraterrestrial intelligence, that is, trying to find alien civilizations that we can talk to. But by and large, if you look at the structure of the equation, it can be used in a variety of situations that are more applicable than just the search for intelligent life. And in particular, what you and I are going to talk about today is, can we use it for the search for life itself, not necessarily just intelligent life? Okay, and I claim the answer is yes, and we'll demonstrate that here in a moment. So the Drake equation is a very straightforward equation. It's just 7 numbers that you multiply together. Those 7 numbers are all things that in principle you can measure about the universe. They're numbers that we can determine either from observational astronomy or experiments in physics or by the statistics of what we know about what goes on in the universe. And if I multiply those 7 numbers together, which you can do on a calculator, you can do it on paper. There's some unit analysis that goes into this to make it all work out. But the outcome of that multiplication is the number n. And the number n there is the amount of alien life you might be able to find. Okay, so when you're using this to search for intelligent life, then n is the number of alien civilizations you might communicate with. Today, it's going to be, the way we're going to use it is n is going to be the number of planets where we might actually find life in the galaxy. Okay, so that's the framework we're going to talk in. In the next lecture segment, we'll take the Drake equation here, as I've shown it to you, and we'll tear it apart, and we'll put some numbers into it and use it to describe how we're going to use this to find, to estimate how hard this problem of finding life in the rest of the universe is. Okay? Okay, well, I think that's all for now, so good luck, and I'll see you in the next lecture.